everybody. Today's lesson is 6.5, using the percent proportion. Now, this involves questions like if a quarter is made out of a core of all copper, which means a quarter is 3 parts copper and 1 part nickel. What percentage of the quarter is copper? Well, 3 parts out of 4 total parts is copper, and you might say, well, 3 out of 4 is how many percent? Okay, we could build it up to be 75%. So there's one way of doing that, but there's another way that I think may be even easier, and I'm going to focus on that. And that talks about just the direct translation from English into math. Okay, so let's go ahead and delve right in. All right, well, let's get back to quarters for a second because it turns out I misspoke. Quarters are made of a pure copper core, and the outer layer is an alloy, which is 3 parts copper and 1 part nickel. So if we were asked to write a ratio that compares the amount of copper to the total amount of metal in the outer layer, that is 3 parts copper to 4 total parts. Well, this is a percent proportion that we want to work out, where one of the numbers called the part, okay, that's the part that is we're talking about that's copper, is being compared to the whole quantity, that's this part right here, which is called the base. So if I were to write this ratio as a fraction, it would be 3 parts copper to 4 parts of the whole quantities called the base. The other ratio is the percent written as a fraction whose base is 100. Okay, so 3 out of 4 is how many out of 100? Well, multiply by 25, multiply by 25, and I get 75, where this is the part, and this is the base. Okay, so we can build essentially equivalent fractions to find a percent using proportions. But I think there may be an easier way to do that just using our math English translation skills. Okay, let me show you what I mean. Looking at this example that asks 5 is what percent of 8? Okay, well, let's go use first the example that we just talked about and the method that we just looked at, talking about the part and the base. So 5 is being compared to 8. So 5 is the part and 8 is the base. So that equals what as a percent? Okay, so 5 is what percent? Remember, if the part of 100 tells me the percent. And from there, what I can do is I can cross multiply because this is a proportion. So I can just cross multiply and solve for p. So 5 times 100 is equal to 8 times p. So 500 equals 8p. And I would divide by 8, try and cram it in there. And I get p is equal to 62.5. Okay, so 62.5%. So 5 is 62.5% of 8. All right, so if you understand that way, awesome. Let me show you another way that might work even better for you. This method uses the fact that math and English translate very well. So I can take these words, 5 is what percent of 8, and translate them directly into math. So the word 5 translates into that number. The word is, what do you think is translates into in math? Hopefully you said equals. 5 equals, 5 is what percent? Well, what does percent mean? Out of 100. What percent? Well, what is something I don't know, so I'm going to use question mark, variable, whatever. So 5 is what percent of, mathematically, what does the word of mean? Times, multiplication, right. So 5 is what percent of, and 8, I could have written 8 there in words, but of 8. So now what I've got, here's another way to do this. So now I've got an equation with an unknown in it. So I'll clean it up. 5 is what percent of 8? So what I can do now is I can do PEMDAS in reverse to unravel this equation. So 5 equals what percent of 8? What do I need to do to get rid of? I'm looking to find this variable. What am I doing to this variable? I'm multiplying by 8. So how do I get rid of multiplying by 8? I divide by 8. And as long as I divide this side by 8, I'm still good. 8 over 8 equals 1. So that makes it look like it goes away over here. And I do this division. 5 divided by 8 is 0.625 equals x over 100. Now I got rid of division, or multiplication, I guess, and I'm dividing by 100. How do I get rid of dividing by 100 on this side? I multiply by 100, really 100 over 1, and I can do that as long as I multiply this side also by 100. So 100 over 100 gives me a factor of 1. So I end up on the right side with x equals, multiplying by 100 moves the decimal 1, 2 places to the right, so I get 62.5. So x equals 62.5 over 100, which is 62.5%. All right, so if you're an equation solver, this might be an easier way to do it. Let's try another example. The reason I like the direct translation better is in a question like this, it might be a little unclear if which of these numbers 4 and 7 is the part and which is the base. So I like the direct translation better. So I would say, if I were solving this using direct translation, I would say what percent, well that translates into what percent of, means multiplication, 4 is the number 4, is equals, and 7. Now I just solve this equation. X over 100 times 4 equals 7. So what divided by 100 then multiplied by 4 gives me 7. So I can multiply both sides by 100, because 100, oops, that should be over 1, because 100 over 100 gives me a factor of 1. So I get x times 4 equals 700. Divide by 4, divide by 4. 4 over 4 gives me a factor of 1. So I get x equals 175. So 175 is, or I'm sorry, 175% is 4. So I can say then that 175% of 4 is 7, right? Because 7 is more than 4, so it's more than 100%. All right, so let's try another example. So in this example, you're being asked what number is 5.5% or 5.5% of 650? Okay, so using proportion, you could decide which is the base and which is the part. Okay, well, given it a percent, that's a little bit easier because this 5.5 is the part and 100 is the base. And hopefully you would be able to say, well, 650 is the base, so I'm looking for the part of 650 that is equivalent to 5.5 parts out of 100. But sometimes that takes a little bit of finagling. So what I really like is the direct translation method. So I could say, what number, if I don't know, what number means variable. What number is 5.5% of 650? So I think if you can get onto this, you'll do pretty well. All right, well, what is, and I just solve this equation. It's even easier because my variable is already isolated, so I just have to carry out this calculation. Well, what's 5.5 divided by 100? That's 0.055 times 650. Now I'd have to go and do some finagling here, and I would say, after I calculate using a calculator, because I didn't want to do this off to the side to be 100% honest, and I get 35.75. Don't trust me? Let me show you. All right, carrying out the whole calculation, 5.5 divided by 100, and then multiply by 650, and we get 35.75. So 35.75 is 5.5% of 650. I think if you can get the hang of this, you may find this one of the easier methods to do. Okay, let me show you another example, because really all of these questions are the same. I'm just moving around where the number is we don't know. Okay, so let's show one more example, because I think we put our unknown pretty much everywhere except one last place. Let's have a look. All right, 52 is 40% of what number? Okay, so 40%, that's easy to tell. If I'm using proportions, 40 out of 100, 40 is my part, 100 is my base. 52, is that going to be the base or is that going to be the part? Okay, well 52 is going to be the part. Well, how do you know? Well, you read it, and it's 52 is the part that is 40% of what number. Okay, that's where, again, I like the direct translation better. So I'm going to say, directly translate 52 is equals 40%, 40 over 100, of multiplication, what number don't know. Okay, and I can go from there. Now there's a couple of different paths I can take that are essentially the same path. I could multiply both sides by 100 and divide both sides by 40, right? Because that's going to get rid of this side. In fact, I'll show you that. If I multiply both sides by 100, that's going to cancel or make a factor of 100 on top, factor of 100 on the bottom, so do that over here. And then divide both sides by 40, or multiply by 1 over 40, same, right? Because 40 on the top and 40 on the bottom cancel to a factor of 1. Divide by 40 on this side too, don't forget. 100 on the bottom, 100 on the top, give me a factor of 1, so I get x equals, and I've got 52, or 100 times 52 divided by 40. Okay, and I can calculate that out. 100 times 52 is 5,200. Divide by 40, and I get 130 equals x. All right, so I could say then 52 is 40% of 130, which makes sense. 40% is almost half, and 52 is almost half of 130, right? Okay, well, let's look at yet one more small way to do this. Let me erase this guy here. My handy dandy eraser out of there. Oops, easy. Come on now, erase for me. Okay, so again, I'm just going to go back and translate. 52 is 40% of what number? All right, well, what I can do is I can do this calculation right here, and I can just turn this percent into a decimal. So I could say 52 is 40% as a decimal is 0.4 times x. So this might be a little bit easier because you can alleviate or get rid of, eliminate, I guess is really what I'm looking for, one step, because I already did this division and turned it into a decimal. So now if I'm multiplying x by 0.4, I can divide by 0.4, and I get the fact that 0.4 over 0.4 gives me a factor of 1. So I get on the right x equals, and on the left I get 52 divided by 0.4, and that is, let's check my handy dandy calculator, there we go, bring this guy in here, and 52 divided by 0.4 gives me 130. So the same answer, of course, because it's the same question, it has to be the same answer, 130. Okay, so I like math. Well, I love math because it's the greatest thing ever. But one of the reasons that I really like it is there's a lot of different ways to view the same question. So you can find a method that makes more sense to you. And as long as you outline, as long as you show your work, you use whichever method you find the easiest. All right, lads, that's it for this time. See you next time.